Okay, here we go. A little algebra 2 review. So we just talked about these graphs, a little review on the board. But what we're going to do is take a function like x squared would be way too easy. X to the fourth minus 5x cubed plus 3x squared minus 4x plus 5 and divided by x minus 1. Now, we can do this by long division, or we can do this by synthetic division. Synthetic division is much easier. Okay? So, to do synthetic division, remember how we made this box last year in Miss Wheeldryer's room? And what goes in the box? Something to do with this. Positive 1. Why is it positive 1 instead of negative 1 that's sitting there? Because we set this part equal to 0 to determine what goes in there. So if the denominator was like 2x plus 5, then you put a 5 halves in there. Or negative 5 halves in there if it's 2x plus 5. Okay? So then you put all the coefficients of the numerator in there without the x's on them. So 1, negative 5, 3, negative 4, 5. You draw a line. Okay? You drop the first one down. That always drops down. What's 1 times 1? 1. The 1 goes here. So you multiply and you put it there and then you add. And you get negative 4. What's 1 times negative 4? Negative 4. And then you add. You get negative 1. What's 1 times negative 1? What? Negative 1, right? And then you add and you get negative 5. And then you multiply, you get negative 5. And then you add and you get 0. This is the remainder. And then this is the function that's left over. If it was x to the fourth here, then this would be x to the third. So this is x cubed minus 4x squared minus x plus minus 5 with a remainder of 0. Okay? Synthetic division. Okay, remember that a little bit from algebra 2? Okay. So we're going to just take a couple examples here. I'll zoom in a little bit. Synthetic division really quick. So what goes in the box? Negative 3, and we go 3, 13, 9, negative 12. Zoom. 3, we get negative 9, and we get 4, and we get negative 12, and we get negative 3, and we get 9, and we get negative 3. So this was s to the third, so this is s squared plus 4s minus 3 with a remainder of negative 3. So what's 3s squared plus 4s minus 3 with a remainder of negative 3? Well, that is choice A. See how that works? Synthetic division. Okay? So you'll have a few synthetic divisions. Okay? Written in fraction form. Because they have another form they have us write it in, but I just excluded all those problems because I don't like that form that they had. So, okay, this one. This one's a little different. Okay? If we set this equal to 0, what do we get? Positive 4. So we have 5. And then see how we skip over from x to the fourth all the way to x to the first? So we have to put in zeros for x to the third, x to the second, negative 4, 1. Zoom. 5 gives us 20, gives us 20, gives us 80, gives us 80, gives us 320, gives us 316, gives us, I have no idea, 1264, 1265. Am I right? Okay. So positive 5x to the third. Uh-oh. And all these are negative. Yeah. I screwed this up. I screwed it up. Because x is negative, since x is negative, if I switch, yeah. Okay, let's try this again, but I'm really close, okay? What you gotta do first, quit it. What you have to do first is change this to negative 5x to the fourth plus 4x minus 1 over x minus 4. We multiply the bottom times negative 1. We multiply the top by negative 1. Okay? To get it at x minus 4. Now, really? Now we go 4, and then 5, negative 5, 0, 0, third, second, first, negative 1, there, negative 5, negative 20, negative 20, negative 80, negative 80, negative 320, negative 316, negative 12, 64, negative 12, 65. There we go. Which would be none of these again. Oh, negative 1265 over x minus 4. So it's plus 1265 over 4 minus x. Yeah, so it would be D. Right? Negative, 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 plus. So what's the... Yep, yep. So there we go. All right, remainder theorem. What's the remainder theorem? Well, what they want to know is, what is f of negative 1 for x cubed minus 9x squared plus 9? Now, I could stick the negative 1 in there and figure that out, or I could use what's called the remainder theorem, which is synthetic division for 1, negative 9, 0, 9. 1, negative 1, negative 10, negative 10, positive 10. 1, negative 1, negative 10, positive 10, 10, negative 10, negative 1. The remainder is negative 1, correct? Well, if we stick a negative 1 in here, we get negative 1 minus 9 plus 9, which is negative 1. Okay? Either way. Okay? It's the same way both ways. Okay? So that's the remainder theorem. Use the factor theorem to determine whether the first polynomial is a factor of the second polynomial. The factor theorem is use synthetic division to see if there's a 0 as a remainder. Because if it's a 0 as a remainder, it's a factor. So negative 5, 1, 7, 7, negative 15, boom, 1, negative 5, 2, negative 10, negative 3, positive 15, 0. Is it a factor? Yes, it is, because I got 0 as a remainder. Okay? If 0 is a remainder, then it's a factor. Looking at this, use the graph to figure out possible linear factors. What are our factors that you see? X plus 2, x minus 2, 2, 4, 6, x minus 6. Okay, so the rational zeros are negative 2, 2, and 6. The complete factorization is this. Okay, that's not too hard, is it? Okay, so then the last one you're going to do is you're going to have x plus 3, x plus 1, and x minus 4. And you're going to FOIL this to get x squared plus 4x plus 3. Multiply it to x minus 4. And you get x cubed plus 4x squared plus 3x. And then minus 4x squared minus 16x minus 12. Add these together to get x cubed minus, because that cancels, minus 13x minus 12. And then if the leading coefficient is -6, then you have to take -6 times everything. So it's -6x cubed plus 78x plus 72. I'm pretty sure that's what they want. Yep. Take -6 times all of them. So once you get your function, take the leading coefficient times everything, and there you go. Okay, so there'll be 9 problems in the first section. Then we're going to come back and do just a little bit more a little later. And then we'll be done with that. Wednesday, we'll review for the quiz and have a practice quiz. Friday, we'll have a quiz because Wednesday's early release. So it's shorter periods. Wednesday. Isn't it Wednesday early release? Okay. What's that for? Teacher in service.